Okay, synthesis. So this one is actually slightly tricky because you realize to make an anhydride is acyl chloride plus acetic acid, right? But I made it symmetric, so just to save you some steps. So this plus that works, and this one can be made from that one, right? So the acyl chloride can be made from the acetic acid. So really you can go like that, as in terms of retrosynthesis. So if you figure out a way of making this one, you can convert that one into that one and then react these two together. So take half your batch, half the batch will react with SOCl2, and then react them both together. So now, but this one now has 4 carbons, so you need to make this one. But that one is easy to make with the Grignard. So let's go over that. So the synthesis would be Br, put magnesium, react this with CO2, and then H plus. Okay, now what you can do after that is say, I'm going to try it this way. I think this one's going to be difficult to correct, and it's going to be a little messy. So we can react this with SOCl2. Oops. And then react these two together to give you the product.
Is it okay if I start off with say bromide and added cyanide and added HCl?
So you react this and then cyanide.
HCl dioxide.
Yeah, HCl dioxide works.
These 2 of those, and I did 1 equivalent of SOCl.
Oh, I see. So you did like 2 of these and 1 equivalent of SOCl2. I think that works. Yeah, that should work. Okay. This one here.
But you have to convert this to CO2? Do you have to convert to CO2?
If you just have 2 acids coming together, it's not going to work.
It's like we take the water out, move it down, and then
If you just mix 2 acidic acids together, it's very rarely going to turn it into an anhydride. Yeah. You need to really force it. Because anhydrides don't want to be made, really. These are very unstable molecules. This is,
heat it, like if you heat it up.
if you heat up a acid, sometimes it'll go intermolecular. Yeah. So this one, it looks like it was made. So this is basically a protecting group for this ketone here, formaldehyde. So it really looks like it was a formaldehyde here, plus its protecting group. Right? But then this has more than 3 carbons, so we have to make this one. I think the way I'm thinking of doing it is with that, and then that. That's the way I would make that one. So you start with this molecule, and then react it with methyl iodide to make this carbon-carbon bond. Then reduce it, then react it and protect that ketone to give you this. So in terms of synthesis, I would do sodium hydride, for example, CH3I, then I would reduce this with, for example, NABH4 or lithium aluminum hydride, giving us this. And then that one I would react with H plus and formaldehyde to give you the protection final product. So just to recap, deprotonation, alkylation. So you add CH3, reduce it, and then use that as a protecting group to make this one. All right. This one over here looks like it could be made from Diels-Alder, right? So Diels-Alder in reduction, that was a way of making things, but last midterm I gave you 4 carbons, whereas this one I'm only giving you 3 carbons, so it's much harder to do it with only 3 carbons. But we know that it could be done from Diels-Alder, right, in reduction, so H2 palladium gives you this. This we know we can make from that, but this has 4 carbons, and I'm only allowing you 3. So does anybody have an idea how to make that diene? Wittig, right? So if you double bonds, we know how to make double bonds by two ways: E2 elimination or Wittig. So Wittig works well here because we can react this with that. Like that. So 2 equivalents of Wittig is going to make that. That plus that gives you this, and this you can reduce to that. So in terms of synthesis, that would be...
Is it weird to have like one aldehyde and then an alkene?
Oh, so if you just start with the alkene, and you just did one equivalent,
3
yeah?
carbons.
Yeah, that works. Yeah, 3 carbons. So the synthesis would be... that with heat, and that with H2 palladium on carbon, giving us cyclohexane. Cyclohexane industrially is actually just made by reduction of benzene. So you take benzene and you put it in extreme heat, extreme pressure with some catalyst, and you can actually hydrogenate benzene all the way down to cyclohexane. That's really how it's done.
Wow.